Hello React Native developers, what is going on? This episode is all about breaking down a seemingly complex problem into small and digestible pieces. So welcome to Can It Be Done in React Native? This week we clean our tabs. Hello guys, I hope you are well. William here, recording from beautiful Zurich, Switzerland. In this week's episode, we are looking at the Google Chrome tab ordering, so I can press on one tab, drag it along, and the tabs in the background reorder accordingly, and there is a super nice transition from one position to the other, and once I release the gesture, it also transitions back to its new position. And when I first saw this example, I got really excited. Because here we have something that needs to be doable in React Native. I mean, drag to sort. If it cannot be done in React Native, I guess we can just pack our things and go home and maybe do some Flutter. So it has to be doable, but I had absolutely no idea how to do it and which primitives I would use to implement such an example. So it got me really excited. So for instance, last week we did the liquid swipe example, which was super experimental. In order for the example to work on Android, we had to do some very substantial trade-offs. But first time I saw the example, I had some ideas of how we would do it in React Native, which primitives we would use. And here it's the opposite. It's something not experimental at all that needs to work, but absolutely clueless on which primitives we would use. Plus, it's an example, not this precise example, but how to drag to sort is a request I often get on the channel. So I'm super excited that we get to tackle it. And usually these drag to sorts are only done in one dimension, mostly vertically. But here we have it in 2 dimensions. But that shouldn't feel scary, right? Because if we do things in a way that is clean enough, whatever we can do in 1 dimension, we can do in 2 dimensions. So how would we do this in React Native? Again, when I got started, I was absolutely clueless how we would do this. And one part I was super intimidated by was how the tabs in the background know where they need to transition nicely in which position. And that felt so intimidated that I was like, oh, I'm not going to deal with this. And I'm going to delegate this part of the job to the transition API. And if I need the transition API to do these transitions for me, it means I need to store the order of the tabs in an array. When I move the card, I call back to the JavaScript userland to set the new order, and the transition API will move the tabs accordingly. This means we would need to play a couple of tricks. So each tab would have 2 versions, one which is in the background, one which is in the foreground and is touchable. And so when I press on one, the one in the background would become invisible, which is the empty space you see here on the right side. And the one that is touch on top in the foreground has an opacity of 1. The other ones are invisible. And then I update the state of the component. The transition API takes care of transitioning the order nicely. That's how I got started, and in fact it works. I was able to implement the fully functional example using this technique. The problem is because we rely on the React state so much, it doesn't perform so well on low-grade Android devices. This is an iPhone X. It's working, no problem. You can move it like crazy. I have a super low-grade Android device. You drop frames like crazy, and if you move very fast, it's not going to be super smooth. Plus, the code was not too complex. It was not too crazy, but was not also super clean either, because we again, we had each tab, 2 versions of the tab overlaid on top of each other and play with the opacity according to which tab is moving and so on. That was not the simplest of solution. And so I was wondering, is there a better way to do it? And I was wondering about the part that is done, the ordering in the background, which I was intimidated by. And I was thinking maybe it shouldn't be so intimidating, and maybe actually what's happening behind the scene is not that complex. So one way we could implement this is by using an absolute positioning on each tab. And this means that the position of the tabs you see is going to depend on animation values and not some state. And there is no tabs overlay on top of each other. Here you would see 3 tabs, you have 3 tabs, and they all have an offset. So the first tab has an offset on X of 0, an offset on Y of 0. The second tab, this one here that I'm pressing here, that is moving, has an offset on X of half of the width of the screen and Y 0. And the one which is expo here has an offset on X of 0 and on Y of half of the width of the screen, right? Because they look like square. So if this one, the Reddit one, has an offset of half the width of the screen, because you see it's cut in the middle of the screen, it means this one has an offset of Y of half of the width of the screen. So we would have these absolutely positioned tabs positioned exactly the way you would see them on the screen. That's fair. Then you start to move one. And when you move the tab according to its position, you calculate what would be its offset depending on its position. And then you select, so of all the offsets values we have, we select the tab which has the exact same offset of than the one we calculated. So meaning here it would be if I calculate the offset of the tab that is moving here, we know now that it would have exactly the same offset than the Reddit one. I mean, here it already moved, but in our example, it wouldn't move yet. And then we would swap this offset. So the offset of the React Native tab, of the Reddit tab, would become the one of the tab we are moving right now, and vice versa. And then we release the gesture, it goes back to position. So we just swipe offset as we move along the tabs. And then, so we do this swapping of animation values. And if this works, here we treat these offsets as discrete values. It's just about treating these discrete values as continuous values, and we can set an animation to go from one offset to the other. Can be a timing function, can be a spring function. So that will take care of, you see, having the tab moving nicely from one side to the other. And that would take care also when I release for the tab to transition nicely. What is interesting here is that I use this feature originally out of necessity, and I've never noticed anything wrong with it. But when you play with the feature in the perspective of can it be in React Native, you obviously do things differently. You move the gesture like crazy and you do some stuff. And I don't know if you noticed, but it kind of feels clunky in some parts. And I was playing around and explaining to you, and sometimes it would, I'm not sure, like not dropping frames, but there were some clunkiness. Hopefully we are gonna avoid such a clunkiness. I mean, we want to have the exact same example, but if we can do even better, let's see. But what do you guys think? Can it be done in React Native? Let's have a look. But before we get started, one thing. So if you are looking to learn the fundamentals of gestures and animations in React Native, especially declaratively, so without crossing the React Native bridge, and do things in a way that run at 60 FPS even on low-grade on the devices, please check out my online course at startreactnative.dev. I'm updating the course every month. In fact, I have an update coming next week, which I'm super excited about. My goal with this course is to provide you with all the tools and knowledge necessary in order to build incredible user experiences in React Native. So I hope you check it out at startreactnative.dev. Alright guys, let's get started. Here is the boilerplate project, which you can download from the video description in case you want to follow along with this example. I have defined 5 tabs here, and as you can see, they are overlaid on top of each other using an absolute position. So the first thing we're going to do is to create some offsets so they display nicely the way they should. So I'm going to create a variable called offsets, and we're going to map tabs into offsets. So we're going to have a tab and an index, and we need to calculate according to the index of the tab an x and a y offset. So in x, the offset on x is either here 0 or tab size, so half, which is width of the screen divided by 2. So either the index you see on the left side is 0, so 0, 1, so is 0, 2, 4, 6, 8, and so on. So either the index is odd and even, either the index is even and it means the offset is 0, or the index is odd and the offset is going to be half of the width of the screen. So we're going to check if if index modulo 2 is equals 0, we know that the offset is 0. If not, it's tab size. And here actually we can modularize 2 by the number of columns. In case, I don't know, we want to have to do it have the example working with 3 columns, for instance. And then we have y, where we basically divide the index by 2 and multiply it by the size of the tab. So index divided by 2 times tab size. And it's not 2, but we need to take the floor value, because, so for instance, if I'm index 1, we divide 1 by 2, it's 0, 5. We do floor, we have 0. So it's 0 times type size is 0. If we try with, here would be index 2. So index 2 divided by 2 is 1 times type size is okay. If we do 3, so it's 3 divided by 2, it's 1.5, which we floor to 1, and it gives us the type size. So that looks perfect. I'm going to pass this offset as parameters. So here we have offsets, which is an array of offsets, and an offset is x animated value. Am I wrapping these into... No, I need to wrap these into animated values, because that's what we're going to animate on. So first we're going to treat it as discrete value, just swap them, and if it works, we're going to treat them as continuous values and nicely transition them. It's interesting because that's the second time we look at Google Chrome, and first time was the refresh button, and we had to use the same technique where we had some sort of complex transition. And the first way we dealt with it first is by ignoring it and treating the animation values as discrete values. And if the example worked without any transitions, then it's all about treating this discrete value into continuous value and do it in a way that is clean. So I'm going to import animated from React Native reanimated value now here we have the offset, so it's x, y, perfect, which we get here, and I can animate animated view, and we're gonna add translate a transform. So with translate X, translate Y, and right now translate X is gonna be offsets at index of X, and same for Y. And that what should give us is to have the tab in their initial state displayed nicely. Why is it complaining? Offsets. Interesting, I'm not sure. Let's have a look. Offsets, sorry about that. You see, this is why we use TypeScript. I mean, I guess this could be catched also by ESLint. So let's have a look. All right, so now they display nicely. Now let's just add a gesture handler around it so it can be nicely draggable. So we're gonna add a pan gesture handler from React Native gesture handler. We're gonna wrap, so we need the gesture handler here, and the gesture handler, we have a helper function to create all the boilerplate for us, because we need to declare a lot of animation values. So we have a helper function from redash, which is called pan gesture handler. Here we go, and this gives us all the animation value we need. So there is the gesture handler, but we need also the state of the gesture as an animation value. We need the translation X and the translation Y. Perfect. So that does a lot of boilerplate for us. And maybe just as a test, a quick thing we can do is here translate X is going to become the offset plus the translation value. Just to see if everything works as it should be. So I'm going to add here translate Y. Oh, sorry, translation X, translation Y, add, we import from reanimated. Okay, let's have a look. Okay, and I can move the card around. So here you see a thing which we can fix immediately is that when we move the card around, it should appear on top of the other cards. Luckily, now Z-index is supported also on Android, and we can also animate on this property. So we're gonna have Z-index equals, so it's a condition, if the state is active, it's gonna be, I don't know, 10. If not, it's gonna be 1. And we can add this property to the view. I need to do some imports here. Okay. Okay, so you see now it's always on top. Perfect. So now let's observe the offsets and swipe the offsets of one tab with another tab when needed. So the first thing I'm gonna do here is to declare, we're gonna declare a function here, because so what happens here is that we're gonna update the offset value. We're gonna do some swapping, sorry, I said swipe. But we don't want, when the gesture is active, we don't want this offset change value to affect the gesture. So here, if we swipe the offset, we would have like some sort of a bump, which we don't want. So we're going to create a special function here to handle the gesture. Let's call it with snap, maybe. And so for X and for Y, we're going to give it, so value is translation X offset. So we can create a variable here, current offset is offsets at index. So offset here is offset.x. So here we have the same with Y. Perfect. And we need the state of the gesture. So let's create this offset. Sorry about that. Let's create with this with snap function. So again, we have a value offset and state, which are, so value is an animated value of number. Same for offset, and state is animated value of state. So we're going to return a block. I hope this is correct. Let me try. Oh, it looks good. So if the gesture is active, so because we don't want the offset change to influence the gesture, we're going to create a new value called safe offset, which is the one we're going to use when the gesture is active. So changing the offset doesn't influence the translation of the moving tab. So safe offset, it's a new value which we start at 0. So if the gesture is active, the value is, so the safe offset plus the value of the translation. And if not, we set the offset into safe offset. So if the gesture is not active and we modify the offset, that's the value we want to use. So we assign offset to set offset, and we can return safe offset. And we need to import set. Let's have a look, and value. Let's have a look. Okay, so yeah, I mean, nothing happens, but because we use this set offset, we can safely do the swapping I mentioned earlier, because it's not going to influence the gesture. So let's just create a use code block with no dependencies. And so let's calculate the offset, the new offset on Y and the new offset on X. So offset X is whatever is the translation. So we divide translation X by the tab size, and we need to floor these values, right? Because it's not an integer. So we need to floor this value and to multiply it by the tab size again. And we can do the same for y. So I need to import multiply floor. So there is a bug in floor actually on iOS, which has been merged into reanimated, but it's not shipped in the version I have. So I think I'm gonna need to play a trick here with the max function. I'll put an explanation probably in the video description. So here it's floor, but sometimes because of a bug on iOS it can return -1. We need to max it at 0. And same here. Now for each offset we're gonna create, or actually I can just so offsets map, so the array we pass as parameter of block is going to be generated from the array of offset. So we get the offset value, and we need to check if there is a value with the same, an offset with the same offsets, and then do the swapping if this happens. So it's if the offset x equals at offset x and the offset y equals as offset y, and if the gesture is active. And state equals state active if this is, so I need to import and. So if this is true, we can do the swapping. So let's swap the x value. So offset x becomes the current offset x. Same for y. And then we need to swap, current offset x into current offset x to offset x. Perfect. And same for y. So we found the tab which had the same offset, and we swap. I really need to make some effort with the English, but we swap the values. So let's have a look. So I move, and you see here it swaps nicely, and if I release, it goes to position nicely. But so you see, I mean, first of all, it runs way smoother than the real app on my phone. So basically we are done. The only thing we need to do is, instead of treating these as discrete values, we just need to transition from one value to the other. That's the final step. So we're going to use a timing function in order to transition the offsets. So we need, for any animation functions, we need a clock. So we're going to create one. We need a timing function, and we know that we're going to need some clock running function, and we're going to need some stop clock, some start clock. And so we need a clock, we need a state. And for a timing function, in state you have position, finished, time and frame time. Perfect. And we need a config. So a config is we have two value, which is a value, a duration. We can use I don't know, 250 milliseconds maybe. And we need a easing. Just gonna use easing linear. Did the import? Yeah, perfect. So we need also now a new animation value, because when we release the gesture, we need to know what was the position here value when the position was active. So we're gonna store this into the position value, just to remember where we were. So from where we need to animate, basically. So state here, it's conflicting, so I'm going to call it gesture state. So when gesture state equals state active, simply memorize the value. Now, if the gesture is not active, so gesture state is not equal at state active, and the no animation is running, so it means the clock is not running, so it means we're going to start the transition. So and not clock running. If this is true, we are gonna start some animation. So I need not equal. And we need to set the true value. So we are gonna go always to the offset value. We need to reset the state value. So we have set state dot position is safe offset plus the transition value, right? So it's going to be safe offset plus position. Perfect. So frame time we need to reset to 0. State and finished as well. So yeah, so finished 0, state time 0, state frame time 0. So this looks good. Do I have okay? And we need to start the clock. Now, if the clock is running, we're gonna run the timing function. So it's clock state config. And if the animation is finished, so state finished equals 1, we need to stop the clock and state set the safe offset to offset. Okay, looks good. And then finally we can return. So here we run the animation, we handle the stop, we return its position, and if we are not animating, so in the else branch, we're going to return the safe offset plus the value. So when the gesture is active, basically. Let's have a look. All right. So here it moves nicely. No, that looks buggy, I think. So here, I know what happens here. Because, so here we reset the position value if the gesture is active. But if the gesture is not active, we need to reset it because we might start the animation twice in a row, even though in between the gesture has not become active. So once we start the clock, we need to set the position to 0. And it's only reinitialized if the gesture becomes active in between. Let's have a look. And I think here there is also a problem. Let's see. So here you see when I release, it moves nicely, but not when moving the tabs. So you see, and it's because sometimes you see it works and sometimes it doesn't. And I think here it happens, and now it doesn't work anymore because the offset has changed in between. So here safe offset should be state.position. So you see here it moves nicely. I can release, it goes back to position. It just works seamlessly. Perfect. Guys, I hope you enjoyed this example. It looked seemingly complex to achieve, but I think we were really able to manage it into really small, digestible pieces. I hope you enjoyed it. I'm looking forward to talk to you guys soon. And in the meantime, happy hacking.